Hello and welcome into my channel. I'm Professor L and I am hosting this live stream for Math Help. If you have a math problem and you would like to see it worked out, and you can post it in the chat and I will give it my best. In the meantime, I have picked out a problem, so I will be working on my board. I'm still doing trigonometry and applications, triangle applications, but I'm going to move on from right triangles. And tonight I'm going to talk about law of sines. And this is a very brief, general introduction to law of sines. It's a, so I'm not by any means trying to like give you formal education on law of sines. I just want to kind of show an example of an application involving this concept. And so what it is they have developed the trigonometric equations for triangles. They basically have developed a rule and a function for using the sine function rather for triangles that are not right triangles. So we're talking about all other triangles. So all triangles have three angles, and all three angles always add up to a total of 180 degrees. But there are different kinds of triangles, and not all of them are right. And what I mean by right, I don't mean wrong. I mean they have a right angle. In one of those three angles is going to be a right angle, and the right angle is 90 degrees. So the trigonometric values that we've been working with and the functions that we've been working with to find missing side lengths and using in the last couple of days the applications, we've been using right triangles, and the trigonometric functions, they're only good for right triangles. So there are some really smart people in this world, and it's somewhere in history. I'm not sure who came up with it, but they figured out how to use the trigonometric functions for all triangles, whether they're right triangles or they could be obtuse or any other triangle in the world. You can still find values. And there's certain values that you need to know. And let me show you how to do it. So, law of sines, real formal introduction. And then maybe tomorrow or the next day we'll do laws of cosines. So basically, in a triangle, let me see. I was trying to figure out how to what I wanted to present tonight. I couldn't figure it out. And I was really, usually if I get started on it early enough, I know by midday, no problem. But I was just really busy and I didn't have a lot of time to think about this live stream tonight. So I just wanted to go in a million different directions. And I thought, well, I want to kind of make it some cohesion here. And so I decided to go ahead and start with the law of sines and cosines, because it is kind of related. It is an applications problem. But here we have law of sines, and if you have a triangle, and remember your vertices are capitals, and then your side lengths are going to be the lower cases opposite. So little b is the side length opposite to angle b, and that's kind of the gist of the triangle. And in this situation, if you have the situation, you can take the sine, and really this is a ratio, and I've found that it works whether you put the sine over the side length or you can put vice versa. So as long as you stay consistent, you can kind of switch it up a little bit. So sine A equal sine B over side B. And what they're doing is they're just establishing a relationship between these two. And then you have sine C is equal to sine C. And what they're doing is they're figuring out, since it's a side length of a same triangle, then they should all have that same proportionality, like no matter what side that you're dealing with. I guess that's the rationale behind it. Again, I'm not an expert. I just completed a bachelor's in math, and I got to spend a little bit of time on this subject, and I liked it. So, yeah, not an expert, but I know a little bit about it. Anyway, so if you have some of these values known, then you can use law of sines to solve the problem and figure out where I put this problem. And right now, I'm just trying to get problems from, I have a really old textbook for trig, and yeah, I've been looking in that to get my problems so far. It's been okay, but it's a really old textbook and it's not very big. There's not very many problems in it. So this one is relevant, and it says a polygon is inscribed in a circle. I'll go ahead and write it out. A polygon is inscribed in a circle. So I think that kind of matters whether the polygon is inscribed in a circle or the circle is inscribed in the polygon. But this one, the polygon is inside the circle, whose radius is 6 inches. So it looks like we have a circle with a radius of 6 inches. And honestly, I've been trying to do better about being planned in when I'm presenting on these streams, but today I kind of didn't have time. So I think it'll work out though. One of the sides subtends an angle of 27 degrees. One of the sides subtends an angle of 27 degrees. So the way that I thought about subtends when I read this was it was the angle opposite. It says at the center of the circle. So I got to thinking about this, and if we have a polygon, that has 27 degrees at the center of the circle, then it says not quite 13 sides. So it's 12 sides and some change. So I got to thinking, what do we even really need to know? How many? Let me see how perfect the circle I can draw. It just looks fat right there. I'm not going to spend an hour trying to draw a perfect circle, I promise. It's better if I start out with the Cartesian coordinate system because that's what I'm used to, but I think I can do better. Let me just go from this direction. And then I'll have to give up. I could spend a long time trying to get this circle perfect. All right. So we have a center of the circle, and we have got this polygon in here somehow. So we've got a circle with a radius of 6 inches. And we've got another radius, we'll just say right here, of 6 inches. And then we've got this side in here of the polygon. And then we've got 27 degrees. So what's going on here is it wants a length of one of the sides here. Hang on, center of the circle. All right, so what's it want? 27 degrees at the center. To find the length of this side. It says a polygon. So one of the sides subtends. So why wouldn't it be symmetrical? I'm gonna have to study a little bit more about polygons, I guess. That's curious. All right, find the length of this side by using the law of sines. Okay, so we just have one. It didn't say two. So we're gonna take this one away. That's 27 degrees, and then we've got 6 inches. So we just don't want to make the diagram any more complicated than we need it. All right, and so it says find the length of this side and it says using the law of sines to do it. So I labeled it S. It's S for side length, real original. And then since I have this triangle here, I'm going to redraw it here. So I have this thing. And what this one is 27 degrees. And this is 6 inches. And this is 6 inches. Then what this is side, angle, side, side, angle, side, a congruency here. And if you have two sides that are equal, this is an isosceles. It's been a while since I spelled it. See if I remember to spell it correctly. I think there's another S in there. All right, I have to look it up now and make sure. Anyway, it's a really hard word to spell, but I have to make sure I got this right. Oh, I got it mixed backwards. Oh, okay, ISOSCELES. Yeah, I guess I spelled it correctly. Finally remembered how to spell it correctly. It just looks weird. That does not look right to me. And it might just be because I'm tired. All right. So we have SAS congruence. And so this is an isosceles triangle. And with isosceles, you have two equal sides and two equal angles. And that's the definition of isosceles. So with that, the angles opposite to these radii will actually be equal. And since I have 180, what I can do, I have one angle known in an isosceles triangle. So what I do is I will make a little equation to figure out these two angles. They're equal, and so there's two of them. So I would just say 27 degrees plus, we'll just call it angle A, plus angle A plus angle A equal 180. And so then that's two angle A's. So you'll have 2A plus 27 degrees equal 180. And then we'll subtract the 27 degrees from both sides. And this is going to give me 2A equal 180 minus 27. And that it was at 53. 153. And then you divide by 2. Is 76.5. So angle is, the missing angle is 76.5. So if we're looking for S in between those two, we've got, we'll draw another triangle. So we've got angle 27 degrees, and then we've got angle 76. 76.5 degrees. And then we've got 6 inches here, and then we're going to label this S. All right, so let me show you how law of sines works. So what you're going to do is you're going to say, let's start with the angle that's known. And I'll call that sine A. And it really doesn't matter as long as you stay consistent which one you label. So I'll just say this is A, we'll say this is B, and then this one will be C. So we're only using A and B. So this becomes side length A, and this one's going to become side length B in this form. So you just fill it in. So A equal 27 degrees. And then little a is S, and little b is 6. So then we're just using these two. And we'll say sine A 27 degrees over side A equal sine B, oops, I was real B, sine of 76.5 over 6, the 6 inches. And so then, however you want to choose to solve this, it's it's an equation with the equal sign. The cross product is pretty good. It's a shortcut. It just basically puts like 2 steps into one. So you'll end up with 6. If you systematically did the steps, you would get the same answer. 6 sine. So it's 6 times sine 27. And that's going to equal S times sine. S times sine 76.5. And now all we have to do to solve for S is just divide off the sine 76.5. All right, so then we'll have S equal 6 sine 27 degrees divided by sine 76.5. And then this is an exact answer. If you're actually using this calculation to make more calculations, then you want to go ahead and plug it in probably your calculator, get an actual tangible value, and then just try not to round. So let's see what we get. 6 sine 27 divided by sine 76.5, and it's 2.8. Let's see. I'm getting, and we'll put exact, but I mean, we'll put all the decimals, but it is just an approximation. 2.8013443366, and that would be in inches. To keep the units, we were in inches, so I have to assume that this was that one of these side lengths is going to be 2.8 inches. All right, and that is my problem. That's basically it. That's all we were asked to do. Brief introduction to law of sines. And I think mission accomplished here. If you are in trigonometry, I guess you would be using laws of sines. Something that was introduced kind of late in the semester. Yeah, all right, good. So that was my afternoon dose of math for the evening. It's good for me. All right, and so then now I have this, a video that I've made, and hopefully somebody will watch it if they need to know how to use law of sines. Hopefully it will help. Anyway, thank you so much for watching, and until next time, I will go ahead and say goodbye for now, and I will see you back here again tomorrow, same time and same place. Bye.